So this is theory of control, week 1, class 2, and we talked about things that can be fatal when you're doing any electrical work. And we said both voltage and amperage can be fatal depending on the amount. So don't be under the misunderstanding that's only amperage. If you look at your car engine, the car electricity, what kind of electricity do you have, AC or DC? It's okay if you don't know. It's mostly DC, direct circuit in your car, and how many volts? 12 volts. Excellent. 12 volts is not that much, right? You can get a 12 volt, guys. You can get a 12 volt battery and put your finger on it and you won't feel anything. So voltage is very low. However, the amperage in this case is very high. How much you draw out of that equipment? How much does the engine require at the spark plug to ignite the gasoline? Around 20,000 volt. So there is a coil that amplifies your amperage to make it very strong and spark. It's not the only 12. So,
Every car is different.
Every car is different. Some have one coil and distributor, some have their own coils, but again, you need to amplify this voltage to be able to ignite the gasoline. So again, there's different kind of voltage and amperage. So even though it's 12 volts, there's a lot of amperage in it. So we said current flow through the body of 0.015 amperes or less can be fatal. Meanwhile, the watts drawn by light bulbs have 0.5 amps, which is enough to kill somebody. So we'll discuss that in a lot of details mathematically and see why does it do that and how do we draw this much amperage later on. But just so you know that amperage, even though they're very low, they can be fatal and they can hurt you. They can cause burns and they can cause tingling, and sometimes they can cause your heart to stop. So voltage is electric shock being zapped. It can give you a big shock. It can cause your system to malfunction. Your heart might have palpitation just from the shock. It can throw you off the ladder because your muscles will contract all at once. When you see something in a cartoon and somebody jumps out of electricity, it's not a joke. You'll jump because your muscles will all contract at the same time. And if you bring a dead animal's muscle, officially dead, and you put some current that you see it contract and expand. So the voltage and can cause that. Being thrown off the ladder, you need always to have non-conductive ladder or feet of the ladder. And here is some non-conductive material, and we'll talk next week about what is conductive and what is non-conductive, and it should make a lot of sense. Codes, we said here in the path that the electricity take is very important. For example, if this guy has, he pulled a chest and he cut off the prong, so there is no ground, and this drill has been tossed around in the van left and right, and one of the wires just got loose and touches the casing, and in the path is to be made out of metal, now they make out of plastic and double insulated. So let's say you touch the drill and your hand happens to be touching the ground, and the current goes through your heart. This could be fatal. It can lead to death. Same thing with the sink. Water is conductive. You touch a toaster, you might be electrocuted and it might cause you to die. Same thing in your bathroom. You always have a special plug called what? Gfci, right? Yeah. Gfci is in the bathroom in any wet areas where if there's any ground, actually what is ground? Any water going where you're not supposed to, it will trip for your safety. So usually in the kitchen or any wet area you have something called Gfci, which is ground fault interrupting circuit interrupter. We'll have to skip it. So again, be always aware of the path and where you put your knee or you touch the ground. Usually when you're working with electrical stuff, you have insulated boots that's not conductive because you don't want to conduct to the ground. That's why they say if you're driving in a thunderstorm and your car stopped, don't get out of the car because the car is insulated to the ground with the tire. Once you touch the ground, you are conductive and you might have some current going through you and you might get hurt. This is what a ground looks like. Ground is usually either bare metal or green. And it's a rod. It's a big copper rod. It's supposed to be the path of least resistance for the current to take. They bury it in the ground in your house, and it's called the ground. So, and it's connected to all the casings. If any wire takes the wrong path, it will touch this ground and go to the ground instead of going to you. Which is more conductive, you or the ground? The ground. So it's going to go to the ground right away. So that's why we need a ground. Did anybody ever had a tower computer, a CPU with the old style from the 90s? And the casing used to be made out of tin, some kind of metallic casing. And sometimes you touch it, it's kind of tingly. There's a ground being activated, or sometimes status, and there is no proper ground. If there's a ground, you will not feel that tingly. If you touch any equipment and you feel a tingly feeling, don't ignore it. There's a ground being activated and something wrong with the ground. One of the wires got loose and it's touching the casing. So that's not something you should ignore. And this is what the ground looks like. And by code now, all new houses have to have a ground. This is the rod. How long the rod is. It goes deep in the ground, and it's supposed to conduct with the soil. And if you look at the control panel here, usually we get two legs. One is the power leg, the hot leg, and the neutral leg. So every house have 220, two hot legs. One leg is 120, the other leg is 120, and we have a third leg that is neutral because you have to have a return, otherwise it's not a circuit. Circuit means something circular. So we have three legs, 110 volt, 110 volt, and neutral. And we also have a ground. So if you want to have a receptacle that is 110, what are you gonna do? You pull one wire from 110 and neutral. Make sense? If you don't understand, it's okay. We're gonna cover this in an entire chapter. If you want 220 for your oven, for your dryer, you're gonna do 110 and 110. It's gonna be two. You're gonna have two hots and one neutral. They call this hot, and this is neutral. We'll cover this later on in a lot of details, so if it doesn't make sense, that's fine. But what I just want you to know is, for a circuit breaker, there's always to be a ground connected to the casing, hot line, and neutral. So again, at homework work, do not cut or remove the third prong. It's very important. It goes to the casing, see? It goes to the casing, and it should prevent you from having any issues. If you get a plug that's 3 prongs and your house does not have 3 prongs, what are you gonna do? You don't cut it. You buy this little extension cord or adapter, which has a fuse in it. The fuse will break whenever the ground is activated. So it's not that expensive, $3-4, but it's a small adapter. It goes from 3 to 2, and it will help you not get zapped if something happens. Especially when you're working with power equipment, power drills, power saws, all this power equipment, because they do draw a lot of amperage. Power tools, double insulated. Some power tools have double insulation, which means the casing is not made of metal. It has the double insulation, so if anything touches the casing, it's not going to go through your body. It's some old designs, or you can get an adapter. Is it okay with power tools? Yes, it's okay, but also read the instructions. So you work in construction and you have a lot of power tools. So the old ones are usually very rugged. They have metallic casing, but you always have to have a ground to it. Yeah. And you'll see in some drills, you see the arc inside when you do it. It is intimidating. Okay, this is another important procedure that we have to do, which is called lockout and tagout. That's the first thing you do before you do any electrical work. And let me show you some stuff. So you always, when you work, you have a small lock with you, and you're the only one who has the keys. And this is a switch, cut-off switch for big equipment. If you notice, it's the on position. If you put it on off, there's a hole here. You're gonna put your little clip on it to close it and put a lock on it. And you also put a tag saying, hey, I'm working on this equipment, do not turn on. And you always cut it off in 2 places at least. You never know. You'll be doing your work in the AC duct. The carpenter comes, he wants to plug in his power drill, looks at the switch and he turns it on, and problem happens. It happens more than you think. It happens more than you think. So you should be very, very careful. So these little tags, buy these little tags, put them in your equipment, get the clips, you have a few of those, and you always get a padlock. Put a padlock on it so nobody will turn it off by mistake. Don't put a twisty, don't put anything that can be cut off, put an actual lock on it, because usually these are high voltage and you don't want anybody by accident coming and open it up. So that's, it does happen more than you think, so be extra careful. So you cut off from the main switch, and you should go to the panel, because every circuit has its own switch. So you go to the panel and you turn it off as well, and put a tag there. And hopefully that will stop somebody from working on it. And let's just hope that there is some kind of coordination between the people working in the house of what's going on and when, so no one, more than one person working the same equipment. So Gfci is what we talked about, is the ground fault circuit interrupter. Gfci. And there is another one, it's called the AFCI, which is the ARC. But this is what you'll see more often in the bathrooms, and I'm going to ask you a few questions about that, and I want you to know it very well. So what it does is whenever a ground is activated, the whole circuit will trip. So it does not just leak the ground to the ground, it will shut off the circuit. Tell you there's a ground somewhere, and you should be careful and go and investigate the circuit. And you'll see it trip a lot in the bathroom. If there's a lot of water, a lot of moisture, something touching the wrong thing, it will activate. The electric device that will open the circuit. So open circuit means it's not activated, right? It's open. So if this is my circuit here, this is open. So it's not a complete circuit. If it's closed, then it's complete circuit and power will go through it. Preventing current to flow in the receptacle when a small electrical leak, the ground is detected. How it works? It's a circuit breaker. What does that mean? It has a magnet in it, and we'll learn that every current produces a magnet. We don't see it, but it's very small. So there's a magnet in it that will pull in the switch whenever current goes through it. And again, we'll talk about that in a lot of details. All I need to know now, it's a circuit breaker that will trip whenever the ground is activated. Questions?
What did you say about the electrical current with the magnet? That
Every current has a magnet goes around it at any voltage or any amperage. There's a relationship between magnetism and electricity that I will explain with a lot of details, and we depend on this relationship for all of our electrical equipment. There will be no motor if there is no magnet working with the current. So whenever there's current, there's magnet. Whenever there's magnet, there could be current. So we have to think about that. Circuit protections. We have two things. Let me see if I have some. So, circuit protection, we want to always protect the circuit from overload. What is overload? If the circuit is designed to run on 5 amps, the wires are designed to run on 5 amps. All the equipment are designed to run on 5 amps. Sometimes mistakes happen, you get 6 amps. What do? If we run 6 amp to a 5 amps equipment, it will burn. So we need a device that will shut off the circuit before this happens. So there are two main types to do circuit protection. One of them is a fuse. Everybody's familiar with a fuse. You have fuse in your car, you have fuses in some equipment. What is a fuse? A fuse basically is a very thin wire designed to melt whenever you exceed that amperage. Why? Because electricity makes heat. We agree?
Yep.
So if you look at this fuse, which actually broken, you can see it's here. You see a thin wire inside. This thin wire is designed to run within 6 amps. Anything more than 6 amps, it will melt. If it melts, there's no current going through it, and we save the circuit. So that's one thing is a fuse. A fuse is basically this is the circuit. Let's put a fuse here. This is the fuse, and it's a very thin wire that will melt if we exceed the amperage. Any questions? You've seen it in your VCR. Probably you know what a VCR, right? In some electrical equipment, you'll see that. If you open your phone charger, if you break it or something, you'll see a small little fuse. In some equipment, they still have fuses. The other device is called a circuit breaker, which will trip by itself, but it requires higher voltage, higher amperage. Because there's a magnet inside. Whenever we exceed the amperage, let's say it was designed at 5, it's getting 7, the magnet around the current going through will be strong enough to pull this in. That's a circuit breaker, and you can go and reset it. Do not just reset out of nowhere. Go check what happened. Why is this circuit is throwing too much? If you have to reset more than one time, something is wrong with the circuit, and I'll tell you why later on. Why whenever you turn on the AC for the first time, you feel all the lights dim, right?
Drawn to the car.
Yeah. Because the motor is stuck, it's locked, and it's trying to stop from the beginning. It's kind of like your car. When you're going from stop, the RPM goes up, then goes down. So same thing with the motor. You require more energy to start. However, that energy should not exceed a limited amount. Otherwise, it will trip the circuit. If you trip the circuit, maybe the motor is more stuck than it's supposed to. So circuit breakers, they are rated by amps, and it's the reason why,
What did you say?
they are rated by the amperage. Like if you look at this circuit breaker here, it says 15 on it, which means this is the limit that it will trip at. Once we reach 15 or more, it will trip. There's another one. Oh, the same one. So they will trip. And that's why we need Ohm's law. I will talk about Ohm's law next week or the week after to understand how does this work. And they are designed for the maximum, for the maximum for those components. What does that mean? So if we go to the kitchen, and we have a circuit there, circuit breaker for the kitchen, 15 amps. So we designed to the maximum of the lowest component. The lowest component, the one that throws the least amount of amperage, and what is its maximum? Let's say the microwave maximum is 7 amps, or 15 amps. So we'll put the protection for 15 amps, so it will not trip. Let's say we have 15 amps, and an equipment that has 10 amps, and it's the lowest component, and we get to 11 amps, and it did not trip because we designed for the highest equipment. Let me put that down. This is my circuit again, and I have oven at 15 amps, and microwave 15 amps, and I have a toaster at 10 amps. What would you put your circuit breaker rating on? 15 or 10?
15.
No, 10. Because if you put it at 15 and this exceeds 12, it's going to burn without the thing tripping. Make sense?
Yeah, but what would you do about the other ones then?
Huh?
What would you do about the other ones you said? You can all set them at different rates.
You put in a different circuit. Put a different circuit for these two if you have to. But otherwise, this one is not protected. You're going to go to 13 amps, this is going to be fine, happy, and this one will not burn. And the circuit breaker did not trip. So That's an electrician job, not our job, but it's good to have an awareness of that. If you have a circuit that keep tripping, check your equipment. What's going on? Maybe this equipment needs its own circuit breaker. What's it? Huh? Okay. So this is my circuit, okay? The maximum amperage for the oven is 15 amps. The maximum for the microwave is 15 amps. The toaster is 10 amps. If I put my protection at 15 amps, this might get to 12 and burn, and the circuit breaker did not do the job. So you put the setting for the lowest component to protect it. Otherwise, there's no use. Probably you go into your car and open the fuse box and you see the amperage on it, 15, 30, and they tell you always do not exceed the amperage. You see this radio installing guy who just put 5 amps extra. Okay, this one keep burning, so I'm going to put an extra one. That's wrong. You're going to burn the equipment. If it says 7 amps, put it at 7 amps. It's there for a reason. So otherwise, check your equipment. Some breakers have 20 amps in residential. The maximum, the normal is 15. 15 amps for all residential, except for one breaker that goes up to 20. And where is that? Usually in the garage. Because you have a vacuum and you have a lot of power tools. So they give you 20 amps for the garage, but if you look at your panel, it's mostly 15. If you have an equipment that requires more than 15, it has its own breaker. If you look at the panel again, go home, look at it, don't touch anything, just look at it. Look at it, and you'll see that 15, 15, 15, you might see the dishwasher with the washing machine that has 30, but it has its own switch. It has its own circuit all the way from the panel, nothing else. So, it will give you an understanding of what's happening. Let me get you a panel so you can look at it.
Burn all those motherfuckers.
So probably you have this in your basement. Sadly, I've seen this installed in somebody's closet.
Yeah, it's in my closet. Pissed.
That is not good, man.
No, it sucks.
That is, sorry, it's a bad design. Because you see, we have fire extinguisher next to each one of
Dude,
them.
I keep one in the bedroom.
So one day you might find it already close a toaster or something.
Yeah.
That's not really a smart design, but anyway, this should be accessible. Nothing combustible near to, close to it, in case something fails. And these are all our breakers. So this is industrial size, so you see like 50 amps here. That is a huge machine. But the little ones are 15 amps. And probably you'll see this in your house. And if the guy who installed it is a very, very organized person, it's supposed to be labeled. That'll be nice.
I had to do it myself.
Kitchen, huh?
I had to do it myself.
Ah, good for you. You're ahead of the curve.
Floors. What do you mean? Yeah, like call somebody, yo, is this the way for
Yeah, I know.
Yeah.
So we also have fuses. Fuses are more expensive. Why? Because you have to change them every time they trip. So you can get a box of fuses over there, and you have to keep changing them. But they are required for some types of loads, and we'll talk about that later. And we still have both. We need both. Sometimes you need a fuse, sometimes you need a circuit breaker. We'll talk about that later. All you have to remember is there are two types of protection: circuit breaker and a fuse. This is the control panel. It's always the main control, and see here there's some kind of label to what everything is. And this is a small residential panel. Circuit breaker. Fuses. These are old style fuses that look like a light bulb, but there are also the tubular ones where you can open them up and change the filament inside. This is the tubular ones. So these are twist off. You can twist it and change the filament if you want to. And sometimes they are clear so you can see if the fuse is burned. So current and heat and melting points. So we talked about current. Whenever you run a wire, it's going to get warm, right? So we understand that when you run current, things heat up, and they make it very, very thin. It's calibrated to melt at a certain temperature based on the current going through it. So it's supposed to melt. I've seen electricians back in the days who just when the fuse breaks, they wrap a wire around it and bypass the fuse. That's very, very ignorant thing to do. Should not do that. Because again, anything happens in the future, you ruin the whole equipment. It's there to protect the board. Again, place a padlock on the circuit. Disconnect in 2 places at least. Remember these. Use warning signs. Inform people around you, whether the owner of the house or any other people are working. So keep this little box with you if you're gonna work in electricity. For our jobs, we're not supposed to do any wiring. You're not allowed to do any wiring. Only a certified electrician can do the wiring. What you're gonna do, you're gonna have a plug ready for you with this switch box that tells you, okay, here's where you're gonna work. You're gonna connect your AC to this or your boiler to this. You are not to go to the control panel. You get to check. So you can go and check, make sure they have the right amperage on it, the right size wiring. But at the end, you're not allowed to touch or unwire anything to the control panel. This is supposed to be ready for you, and you hook up your AC or your boiler to this switch. And you're allowed to do that once you pass your oil burner test. So, which is very basic. You have to do all your controls, all your wiring, and at the end you plug it into the source, and it should be fine. If it doesn't work, you call the electrician and see what's going on. So you gotta have at least a padlock with you, those little clamps, and signs. So do that before you try to connect anything. General guidelines. So follow the codes when it comes to the wiring size, and usually when you go to the warehouse, they have the updated gauge size. What is the gauge size for the wire? Again, we spend a lot of time talking about that. We said every wire requires its own gauge, which means thickness. So thin wire might heat up faster. For now, our gauge is gauge 14 for a wire. So we're gonna keep that in mind, and we'll get used to it a lot because we're gonna work with gauge 14 a lot. Make sure they have you have the approved equipment when it comes to switches, wire nuts, tape if you have to, or other connections. Make sure the power supply is shut off. The control panel, proper power lockout. Keep out from damp surfaces. If the area where you go to fix the boiler is damp, disconnect the switches. Make sure the area is dry, then start working. Because again, water is very conductive, especially when it's salty, and most water is salty, so it will conduct something and it might hurt you. Keep out from damp surfaces. Be aware that when working on electrical circuit, again, not every basement is ideal and put the right way, and the person might put it the right way, but then the owner came and he put some boxes, and he put some washing machine, kids' toys, exercise machine, total gym, and at the end it's really hard to access the boiler. And actually, I kid you not, I went to somebody's house and I saw the boiler and the burner with boxes over it. But how is this getting air? And this is actually, you know what happens? People do not understand there is fire inside because they don't see it. And psychologically, they don't want to see the fire, so you won't freak out. Or you don't see the fire, but there's fire inside. But people don't appreciate that the guidelines says 5 feet from any combustible material. It should be 5 feet everywhere. But I see people putting boxes on it, papers, what have you. At the end, the boiler does not perform as it's supposed to, and it's a big fire hazard. So make sure it's clear, and inform people that you should not put stuff in there. So make sure the area is clear and safe before you start working. Only use ground equipment. Just in case something happened, use ground equipment. Have a little extension cord with you in case. Do not wear rings, watches, or any jewelry or metallic stuff when you're working. Pay attention to that. A lot of technicians, they do not wear wedding rings or like jewelry or anything that is loose, because it will be a good path for the current to go through.
So
Huh? And this is fine, you know, but big stuff in your hands, you know. If you're working with something and suddenly touches equipment, it might zap you, it might be.
So,
yeah.
I have a question. I've seen burglars in closed, like closets.
Yeah.
That's not regular either, right?
No, but it's an old house.
Oh, okay.
Or probably it's an old house.
Alright.
So a lot of things get grandfathered in because they're old.
Alright.
But the new stuff, you cannot have that. But somebody had a house already from the 20s. What are they gonna do? Tear it down?
Mm-hmm.
I mean, it costs a lot of money. So they grandfather it. Wear shoes with insulating sole. That's very, very important. Get the shoes that have very thick rubber insulating sole, insole and sole, and also don't slip, just in case. So you have good footing, and you also do not lift up to the ground. Do not use metallic ladders when walking near live circuit. That is no brainer. And people like the aluminum one because they're lightweight, but now they have fiberglass, which is as light and strong. So use that. Examine all wires and power tools for damage before using them. Again, you'll be surprised how much the wire looks very loose, and covering seems all stranded, and people still work on them. Do not do that. Examine it, make sure it's very sound. And yes, it might take you like half an hour to change the wiring on a power tool, but it's completely worth it. Same with the equipment. If you go to an equipment that has a lot of loose wiring, where the cat's been playing with it, or mice chewed on it, again, pets are really annoying when it comes to these things. A lot of times the cats will chew on the wire, and the issue is they will chew on the wire, they will cut the wire from the inside out, but you still see that insulation. So we'll learn how to trace the wire, make sure it's sound. So do not work with loose wiring, change the wires. When using measuring tools, make sure they are in good conditions. It will be very confusing if you have a multimeter that's not functioning well. Have a secondary one to have comparison to, or have something that you trust that you know the output of it. Example: get a multimeter, you're trying to measure the voltage. It's giving you some funky voltage. Have a battery with you. If you know this battery is 12 volt, and go and measure and make sure it gives you 12 volts. We'll have a resistance ready to just compare and calibrate. And mostly nowadays, if you buy a new multimeter, it's very accurate. It's digital. So the area of error is not that big, so it should be good and calibrated. This is what we were talking about before. When helping somebody who's locked in and electrocuted, do not touch him. If you can, use something insulated, like a piece of wood or cardboard, and try to push him away in a knocking motion. Because if you touch him, you might be conductive as well. You might be stuck as well. So try to knock him out of the circuit, and of course, call an ambulance as soon as possible. But yeah, your instinct is will be, if you're a return, gonna pull you, and that's not the right thing to do. So make sure you push him away, so you're not be part of the circuit. And I'm afraid you're gonna push him away and you're gonna break something. Just get a towel or something and just like push him away, or a piece of wood, and just knock him out a little bit in a knocking motion, not pushing, just knocking motion. And if he's not breathing, you can do some kind of quick CPR on him, like just keep him breathing. And the best thing they say with keeping somebody breathing from the latest CPR attended is just like pushing on the chest cavity rhythmically, just to keep the lungs going up and down, keep him breathing until the ambulance comes in. It will be very, very helpful if you can take a CPR course. It will look really good in your resume. We offer the CPR here in school, and we also offer OSHA 10. OSHA 10 costs you like $75. You can do it here in school, and it will be really, really good for your education. Yeah, most companies offer like OSHA 10, OSHA 30 instruction. So, it's gonna be not this homework, next homework. Let's recap on these little pieces of information. What is a live circuit? Any circuit with current going through it. Makes sense? Simple as that. What type of voltage will you encounter in HVAC as an HVAC technician? AC or DC? How much? It's going to be mostly the AC. For all our equipment is AC, alternating current, and it's going to be around 110 volts, and hard labor sometimes 220. So it's not that much, and it's only single phase. We'll talk about what single phase means later on. When do one get an electric shock? When you become part of the circuit. So you see birds standing on power lines and they don't get electrocuted because they're not part of the circuit. So I don't know how accurate it is, but in movies when somebody is jumping the power line and hangs, that's okay, as long as they don't touch the ground and they jump before they finish. So in theory, that's right, but I don't know if it's Completely correct. Do you remember that Mythbuster episode when they were trying to validate the idea that if somebody in a construction site urinate on a transformer? What was the conclusion? I remember I've seen the episode and they said, okay, the urine is full of electrolytes, and the story goes that somebody was in a construction site and he was urinating from the second floor, and the urine touched the transformer, and since it's a continuous stream, he get electrocuted. In theory, it makes sense, but I really don't think it's gonna be the way the story goes. The story is funny, but it's
they busted that.
yeah, I think it was busted. It was not correct. But the idea is you have to be part of the circuit. So if you touch a wire but you're not connected to the ground, you might get away with it. But if you become part of the circuit, that's when you get electrocuted. Oh, what happened? Give an example of being electrocuted: touching a live circuit, having a hand in water and touching a circuit, being part of the circuit. Would you get injured if you touch a live wire with your index and your thumb is touching the ground? You get injured, but you might not die. Because you're connecting your hand, you might get burned. You'll get injured, but it's not very fatal. It's from hand, it's one hand. What about if you touch a live wire and standing on wet ground? You'll get injured. What is the standard applied in the US for electrical installation? What is it called? NEC, National Electrical Code. NEC. NEC, National Electric Code. So, the industrial code goes like the laws. The national code goes everywhere. The state code has to be higher or equivalent to the national code, right? Cannot be lower. The county code or the city code has to be higher than the state and the federal. It's the same as the law. So your law can be higher, more stringent, but not less than the national code.
So county can be like.
Yeah, like some cities here are very, very stringent with their codes. But compared to the state, and the state itself has higher code than the federal, but it cannot be lower. So the national code goes everywhere, but the state and county codes can be higher, not lower. Think safety first. Better be safe than sorry. Sometimes you just want to drive back to the warehouse and get some stuff, so don't do that. Don't risk your safety or others for any reason. No matter what people call you, whatever money it costs. If you don't feel safe, you don't feel safe. Go with your gut feeling. And sometimes it's good to stand for what you think is right, and don't jeopardize your safety. Security evolves with knowledge. The more you know about the system, the more secure you feel, and less fear you have with the equipment. And as much as we're gonna know now about the voltage, what is fatal, what is not, what you can work with, what is the insulation, the more you'll be brave, the more you'll be to work with these stuff. What current flow is fatal? 0.015. This is fatal. What kind of flourish do you use if you are going to work in live circuit? Fiberglass, wood, not metal. How would you help somebody who's being electrocuted? Push him away. One motion.
Could you kind of give him a check, like a shoulder check and knock him out of the way?
No, you don't want anybody touching at all.
At all?
Yeah.
What about a kick? I feel like a kick would be bad.
Say that
A
again?
kick?
Still.
Like you're kind of touching with your shoe.
You're gonna break his ribs on his hip.
Better than him dying.
You know, boxing, just push him.
But that's mad long.
What if you can't find a box?
Carry boxing shoes and stuff.
I don't know, but get something sling in the jail, just push him. Okay. Can you cause a fuse? Can you use a fuse that's larger size than installed one?
No.
No, that's a big no. So 5 amps and 5 amps. Do not use 7 amps. What is the difference between 3 and 2 prong plugs? Yes?
The ground.
Ground. What is GFCI?
Ground fault circuit.
Excellent. You are in a team of 6 working on a house project. You are installing a boiler. What is the first thing you would do?
Check the circuit breaker.
Tell everybody, I'm working on a boiler today. Cut the circuit in 2 places, lock it, and tag. I'll be working on this today, put the date and time, and put a lock on it so they cannot activate it. Alright, so that's what I have for you for this week. If you can please read first, the first chapter is very entertaining. It's nice, it's important. And try to do the homework online, and if you have any issues, bring them to me on Monday, and we will discuss that. Thank you.